All right, now section 2.8, we have what's called cis and trans isomers. All right, cis and trans isomers only occur on restricted bond rotation molecules. I know it sounds a little weird, but it's basically molecules that have a restricted bond rotation. If you look at a cyclical compound, let's take cyclohexane for an example, okay, I cannot take this bond right here and rotate all of the groups all the way around. Okay, I can't rotate the bonds at all. These bonds do not rotate. All right, like how we saw with a straight chain molecule. All right, let's say I have a straight chain molecule. I can easily rotate around that bond. So this group right here can be rotated all the way around and all the way around the other way. I can rotate these bonds. Okay. Well, these cis and trans isomers only occur on these molecules where you cannot rotate the molecule. Because if you can rotate them, you don't have cis and trans. Okay. So it only occurs on molecules that do not have rotation. It occurs on cyclical compounds. We'll also see that this also occurs on alkenes, which will be, I believe, next chapter. Okay, so let's talk about what cis and trans implies. Okay, let's take a three-membered ring, a cyclopropane. I'm going to try to draw it three-dimensionally. Okay, and what you have is you have hydrogens that are kind of on the top of this molecule, and you have hydrogens on the bottom of the molecule. Okay, see these three hydrogens, like that's kind of drawn bad, but these three are on top. The hydrogen should be more down like that. And then you have these three hydrogens that are on the bottom face of the molecule. Notice that no matter, I can't rotate these carbon-carbon bonds so that these hydrogens are then on the bottom and these hydrogens rotate on top. If I turn the molecule around, that's one thing, but I can't rotate them. So because of that, if you have different groups, let's say you have methyl groups. So let's say we have this molecule where you have a CH, where both of your methyl groups are on the top face, and you got hydrogens coming down. All right, I'm not going to draw the hydrogens there, just to show you the difference between the cis and trans. So these hydrogens are on top. There's nothing I can do to this molecule to put one methyl group on the bottom. Okay, that is a different molecule. That would be a CH3 here with the hydrogen down there, hydrogen here, and the methyl group on the bottom. And our frame of reference is the plane of the molecule. Okay, I'm sorry, the plane of the carbons. Okay, so this would be the top face. These hydrogens would be on the bottom face. Okay, so these are what cis and trans isomers are. When the two methyls are on the same side, that's the cis isomer, for same side. And when the two methyl groups are on the opposite sides, that's called the trans. Okay, opposite. All right, so I'm kind of drawing a three-dimensional structure, but you can actually draw these in a two-dimensional with wedges and a dotted line. All right, so I can take a cyclohexane, and if I draw a wedge here, put a methyl group here, and then do another wedge at the 4 position, all right, these groups are on the same side. So this would be the cis isomer. You can also draw it where you have one of them is wedging out, meaning coming out towards you, and the other one, the other methyl group, is going back. Okay, now what I didn't draw in there is the imaginary hydrogen. Not imaginary. I didn't draw in the hydrogens. Okay, so technically on the molecule on the left, you would actually have a hydrogen going back and another hydrogen going back. So notice your hydrogens are on the same side of the molecule and your methyls are on the same side of the molecule. What I would do is make models if you can't see this. Okay, the models will be very easy. In class, in lab, our first lab, we'll do an actual model lab where we make the models of all these molecules and you'll be able to see it. So here your hydrogen is going back, but here your hydrogen is coming up. I'm just kind of doing it little so so that it doesn't encumber the molecule. So these are two technically different molecules. The molecule on the left would be called cis 1,4-dimethyl cyclohexane. And the molecule on the right would be called, I need more room here, so this molecule, that's the name of that molecule. This molecule is called trans 1,4-dimethylcyclohexane. All right, and these are isomers, but these are in particular called stereoisomers. So we learned about constitutional isomers, same formula, but the structures are completely different. Stereoisomers is same molecule, but they are different in 3 dimensions, let's call it in a 3D orientation. So they are connected to the same atoms. That's the important thing. The connection is the same. Connection is the same. What do I mean by connection? I mean that your methyl groups are still connected to the 1 and the 4, and you still have a cyclohexane. A constitutional isomer would be if you have like a 3-membered ring compared to the 6-membered ring. I mean, the molecule is just totally is a different molecule. There's nothing similar about it. But these molecules, I mean, are almost identical. It's just how in 3 dimensions they are not the same. So that's what a stereoisomer is, and we'll learn a lot more about stereoisomers later on in the semester.